going to cheat and start this 1 minute early because I can. So, picture this. I was sitting in my office and the phone rang and I recognized the number. It was a friend of mine, a developer friend of mine, and I picked up the phone and I went, hello, and it was dead quiet on the other end, as in not a sound. So I just is about to say hello again, I just hear his voice go, SQL Server hates me! And I go, oh, okay. And I thought about it for a second and realized that no, it does not hate you specifically. It hates everybody just as much. And that was the inspiration that I needed for creating this session. So it's basically taking developers from this to something slightly more constructive. So, my name is Alexander. I am from Sweden. I have the best title in the world, Principal Solutions Architect, because nobody knows what that means. I go all over the world, teach, train, speak at conferences like this, and in short, I make data matter because only data that matters can actually inspire any change. So let's start with memory. SQL Server has the same opinion of memory as my cats do food, as in they want all of it. Now, immediately. I'm going to give you a number, and I'm curious to see if you know this number. It's a pretty big number. I'll give you a hint. It's in megabytes. That's a lot of megabytes. So this is the amount of memory that SQL Server will use out of the box, or be allowed to use out of the box. Now, I don't know about you people, but very few of my clients have boxes with 2 petabytes of memory as RAM. So why do we still use this as a default number? Because it's going to eat all the memory on your box. So my first tip here is never accept the automatic, the default settings. Always set a specific number. And when it comes to memory, when we think about memory, we think about a specific number, right? Most of my clients are from Europe, and in Europe, we're generally more inclined to use SQL Server Standard Edition. And Standard Edition comes with a few limitations. For instance, you can only have 128 gigs of RAM in a SQL Server Standard Edition machine, right? No, that's the thing. So when we think of memory, we think of the buffer cache. This is where the magic happens, right? But there are so many other things in SQL Server that requires memory that is not specifically the buffer cache. And this means that the addition memory limit only applies to the buffer cache. What does this mean in practice? It means that I can do this. I can actually put 192 gigs in the machine, cap the max server memory setting in SQL Server to 166 gigs, and SQL Server will be able to use all the 166 gigs. The only thing that it can only be 128 gigs is the buffer cache. Thus, if I put in 166 gigs, I can actually use all of my 128 gigs that I paid for to get out of the buffer cache. That's top tip number 2. The next thing is parallelism. And parallelism is not only very difficult to say if you're not a native English speaker, it's also a pretty difficult concept to grasp. So what is parallelism? Well, this is parallelism. You can see it with these small yellow arrows. What it means is that if I was to have a huge bowl of skills, and I want to sort this, I just go blue, put it over there, green, yellow, blue. I'm going to be here a while. So what I'm going to do is I'm going to take this bowl and give each and every one of you a small pile of the skills, right? Then you sort them and give me back the result. That works perfectly in theory. Unfortunately, at least one of you, probably 2 or more, are going to be glued to your screens, looking at Twitter, Facebook, cat pictures. I don't know. Everybody does it. And unfortunately, I cannot get my result back until everybody has sorted my skills. That's what's known as parallelism skew. And parallelism skew is what generally kills parallelism in an online transaction processing environment as opposed to a data warehouse environment. So what can we do about this? Well, a couple of ways. There are two settings. Well, before we go to that, this machine, this specific machine is the machine of Gene Amdahl. He wrote large parts of the optimizer, or the cost optimization part of SQL Server back in the day. I used to have one of these. Yes, I am that old. And the trouble is that that machine kind of set the bar, because there are two numbers that we need to take care of. Cost threshold for parallelism, 5. 5 meant that the query would take 5 seconds to run on that specific box. Now, there has been some developments since that Pentium box, just a few. So something that took 5 seconds on that machine to run does not take 5 seconds today. That means that number is completely arbitrary. Max stop means the max degrees of parallelism. How many CPUs should we rope in to do this query? 0 is by far the worst number you could ever put there, because that means use all the CPUs. That is generally not a good idea in an online transaction processing environment. It's a good idea in a data warehousing type of scenario. So here's my tip. Set the max stop to 1, 2, or 4, depending on the number of CPUs. I mean, if you have 64 CPUs, it makes more sense to set it higher, but that's a good rule of thumb. 1 means that you can only use 1 CPU per query. In some cases, that is a good idea. Some cases, that is a bad idea. Anybody ever use SharePoint? Yeah, SharePoint requires you to set this to 1. When it comes to cost threshold for parallelism, I recommend you to set it to 50 for starters. This is a starting number. You do not want all your queries to go in parallel. That is going to kill your performance. You roughly want to keep about half of them do parallel. And that's just a rule of thumb. So start with 50 and then keep track of your cache to see if it goes up or down. Starting numbers again. Sets versus row by agonizing row. Has anybody ever done any laundry? Nobody? Okay, this is a very smelly conference. So, laundry is generally done in one of two ways. Either I can go pick my garment out of the laundry, I fold my garment, and I put it away, and then I take my next piece of garment, I took it out, I fold it, and I put it away. That's row by agonizing row. Or I can just go do the laundry. This is key. There are two ways of telling SQL Server to do something, and that is set-based or R-bar, as in row by agonizing row. This is what it looks like. This is a cursor. Cursors are generally bad. Friends don't let friends use cursors. Just saying. They have their uses, but they are few and far between. So what it's doing, it's opening the cursor, and we are iterating over a set of rows. Now, it turns out that there is a much better of doing exactly this. Do an update. So what we just did, this is going take garment, fold garment, put garment away. And this is do the laundry. Always tell SQL Server what to do, not how to do it. It's perfectly capable of screwing things up on its own. Search arguments. And this one is kind of funny because, let's give you an example. Do we have any issues with this? It's perfectly valid code, right? Because SQL is so easy to learn, and while the code will run, the code will compile, so to speak, it doesn't necessarily mean that it's a good way of doing things. So SQL is like checkers. It's easy to learn, but it takes a lifetime to master. And that's exactly what I see happening over and over and over again. What I want to do here is I want to take a part of my date join field and do a query on it. Unfortunately, that is the whole date, but I just want to have the year part. So thus, I use the function of year to just extract that from date joined and query on 1953. Unfortunately, SQL Server being different from other databases on the market, one instance is a red database, which I will not name. you cannot get an index on the result of this query, or on the result of the function, I should say, easily. There are ways around it, but this is the way it works out of the box. So this means that SQL Server is going to go, okay, he is querying on date joined. If I had just gone on date joined equals 1953, I could use the index to find 1953. Unfortunately, I am not querying on that. I am querying on the result of a function, year, in the date join. And that is not in the index. So SQL Server is going to go, can I do this via an index? Nope. Oh yeah, just get this up and let's go. And it's going to go through all the data. That's known as a full table scan if it's just a table, or a full index scan if it's on an index. It takes about a week. So don't do this. Do not do this. Do this instead. I'm doing kind of the same thing. I'm converting my date time, and I'm specifying 1953. I'm slightly more specific in this case, but the gist is the same. But the key here is I'm doing where date joined equals. I'm not doing where year date joined equals. It's a whole different kettle of fish. This I can get through an index. And this means that this is going to be blazingly fast. Much, much faster than this one. This is not going to be an issue over 200 rows. But it turns out that very few people are content with 200 rows. Everybody and their cat is amassing data, and suddenly you're looking at millions and millions and millions of rows. This is a simple trap to fall into, so don't do that. Then it comes to sorting and memory. So the human mind has a tendency to like sorted lists. Unfortunately, that is a horrible idea from a computer perspective, because sorting is not only very, very expensive, it is also what is known as a blocking operator. That means that nothing can be done in parallel through a sorting operation. Everything has to stop until the sorting operation is done. And the trouble with having humans writing code is that it's so easy to just tack on an order by when you least expect it. So there are some differences, some subtle differences, as I'm going to show you in the next slide, of these queries. This one creates an ordered list, this one does not. And if I don't need an ordered list, stay as far away from order by as you physically possibly can. There's also an implicit tip in this. I'm doing where date joined larger than equals and less than. Why am I not using between? So between is another way of doing the same thing, but between is dangerous because between is inclusive on both ends. And there is actually pretty old blog post written by Aaron Bertrand that deals with this whole thing, and he basically explains why between is evil, and that kind of fit in my session. It is evil, so try to avoid between if you can, because it can give you more data and actually unexpected data, and we don't like that as DBAs. So, having seen this a bit, order by, no order by, these are the different query plans that we have. So the order by costs 95%, and the one without the order by costs 5%. So we're looking at a query cost of 34.5 somethings and a query cost of 2. Now these 34.5 somethings, they are bananas or apples or small tractors. It doesn't matter. You cannot compare my 34.5 to your 34.5 unless you have an identical machine. As soon as there is any difference between the machines, the numbers are completely useless. The only thing that we know is that the first query is a heck of a lot more expensive than the second query. We know this because it's a lower number and it's on the same machine. But hey, it gets worse. There's a teeny tiny exclamation mark over here. And that is because this sort spilled to disk. SQL Server was not expecting the sheer amount of data coming back out of this. And the sort operation kicked the whole thing off its rails. So this means in this specific case that the sorting forced its way to disk. So not only is this a much more expensive operation, we also incurred the penalty of writing to disk and reading back from disk. Whenever you see an exclamation mark, run. It is a bad thing. So if your developers come to you as DBAs and say, I have this exclamation mark thingy, fix it. Because it's going to be an issue, a serious, serious issue. So in summary, this is what happens if devs and DBAs don't talk to each other. People are going to get hurt. Things are going to break. And it hurts me to see the divide between us and them. It doesn't work that way. I, as a DBA, cannot get anything done because I have nothing to offer. Tech is just a tool. We're just humans. I cannot do things on my own. The devs, on the other hand, they cannot get things to run on their own. I need them, they need me. Together we can really, really, really get to do things. So here's my top tip to you. If you're a dev, go find your DBA and hug them. If you're a DBA, go find your dev, hug them back. Seriously, guys, there's so much to do if we just do it together. So go out, do it together, make awesome code, and have great fun. I'm Alexander, I love data, and thank you so much for coming.